Okay, in today's topic, we look at more complex problem on area and the volume ratio, and the learning objective is to solve more complex problem on area and the volume ratio, and these are the key words. Okay, and the last time we treated on this, we noted that if the length ratio gives us x is to y, if the length ratio gives us x is to y, that means that the area ratio will give us x squared is to y squared. In the same way, the volume ratio will give us x cubed is to y cubed. Please don't forget this. We always use this in solving problem on area and volume ratio. Okay, now let's look at this problem here. It says a manufacturer makes a range of crown cards that are all similar in shape. The smallest card is 5 cm tall and uses 169 cm squared. So 169 cm squared means the area. What will be the height of the card made from 361 cm squared of a card? Okay, so that means that we are given that the smallest card is what, 5 cm height, and the area is 169 cm squared. And the big card, we don't know the height. We are asked to find the height, but the area is this. Okay, now in this case, we have to first of all find the area ratio, because the two areas are given. We find the area ratio, which gives us the smallest card, which is 169, is to the biggest card, 361. Okay, now for us to find the length, which means that we need to find the square root. The length means the square root of 169 is to the square root of 361, because length is x is to y area is x squared is to y squared. So to convert this to this, you find the square root of this. Okay, now from here, the square root of this, which we know is 13, and the square root of this is what, is 19. Okay, now for us to find the height that produce 361, we say let the height be h. Let the height be h. So that means that if I have the height to be h over the height of the smallest one, 5, that would be the length ratio of the big one, 19, over the smallest one, 13. Height big one, h, height small one, 5, ratio big one, 19, ratio small one, 13. You see how? Now from here I have to cross multiply, and that gives me that h will now be what? Will now be this times this, 5 times 19 over 13. So check 5 times 19, 5 times 19, that gives us what? 95. We have 95 divided by 13. So 95 divided by 13 give us what? Okay, this is a recurrent. We have 7.3. okay, so that gives us 7.3 cm. That's how we solve the problem. Okay, now let's look at another question. This says the volumes of two mathematical similar solid are in the ratio this. Pick it one after the other. The ratio, that means volume ratio is what? 8:125. Okay, the surface area of the smaller solid is this. Work out the surface area of the larger solid. First of all, since the volume is this, the volume ratio is this, I'm going to find the length. Always find the length. Always find the length. The length ratio. Now the length ratio will give me this, the cube root of 8 is to the cube root of 125, because length is x is to y and volume is s cube is to y cube. So for me to transfer from here to here, I'm going to find the cube root of this. Okay, that means that the cube root of 8 is 2. Use a calculator. Cube root of 8, 2 times 2 times 2 to 3 places gives us this. Okay, and the cube root of this is 5. Now you say work out the surface area of the larger solid. Now for us to work out the surface area of the larger solid, we need to first of all find what? The area ratio. So the area ratio is the square of the length ratio, because length ratio is x is to y. That means area ratio will be x squared is to y squared. So it means I'm going to square this. That gives me, if I square this, I have 4 is to, if I square this, I have what? 25. Okay, that is 2 squared is to 5 squared. 4 is to 25. Now since I've obtained the area ratio, I can now find the area of the larger solid. So if the area of the larger solid, let me say, let the area of the larger solid be x, or let me use small a. So that means that small a of the larger solid divided by the smaller solid is 24. Then the larger area ratio is 25. I have 25 over the small is what? 4. Then in this case, if I cross multiply, I will have that a, that's the area of the larger solid, will gives me 25 times this, 24 times 25. Whatever I have, I'll divide it by 4. So that gives us what? We have 24 times 25. That gives us 600. 600 divided by 4. We have what? We have 150. So 150 is the height. 150 is the area of the larger solid. So 150 cm squared is the area of the larger solid. Okay, now let's look at this final question here. This says that a cylinder has a volume of this, and similar cylinder was made out of the same material, but is only 2/5 of height, 2/5 the height of the first one. 2/5 the height of the first one. Work out the volume of the smaller cylinder. Now here we are given that a cylinder has this is the volume. A smaller cylinder was made out of the same material, but what 2/5, that means 2/5 and 2 over 5, it gives us what? The volume. That gives us the volume what? The volume 2 over 5 gives us what? The length ratio, and that means 2:5. So in this case, we are going to look for the volume ratio, and the volume ratio simply means we are going to find the cube root of this and find the cube root of this. So the cube root of 2 is 8, and the cube root of 5 is 125. That is 5 times 5 times 5, 125. Okay, now since we have obtained the volume ratio, we can now go here and say that the cylinder has a volume of this, and we are looking for this volume of the smaller cylinder. Okay, so we can say let the volume of the smaller cylinder be C. Let the volume of the smaller cylinder be C. So I have C over the big cylinder 840, which is equal to the volume ratio of the smaller is what? Is 8 over the big one is 125. So if I cross multiply, I have that C is equal to what? 840 multiplied by 8 all over 125. Okay, let's check what we have. We have this to be 840 multiplied by 8. Whatever it gives us, we have to divide it by 125. So if I divide it by 125, we have that to be what? To be what? What do we have that? That gives us 53.76. So that gives us 53.76. So this gives us what? The volume of the smaller cylinder. Okay, so that's how we solve the problem. Thank you for listening. Bye.